Good day, everyone. My name is Wayne McAdams, and today we're going to be doing a little bit of a presentation on making data-driven decisions in the control room. And we have a couple users to give us some experiences that they've had doing this. Here's a little information on how to dial in if you're having trouble with audio. We've got a number here with access code and audio pin. Also some other resources. If you would like to ask questions, you can email questions to the email address shown here. Also, we have some additional resources, our community forum link, and the general dataPARC website. As I said, I'm your host today. My name is Wayne McAdams. I've got 2 decades in pulp and paper process control, and half that time I was one of dataPARC's first customers. So I spent a decade using dataPARC in control rooms, and I spent my last 16 years with dataPARC continuing to develop cross-industry solutions. Reagan?
Yeah, so my name is Reagan Malloy, and I'm a process engineer at RIAM, formerly Rainier Advanced Materials. I've been working with PARCview here for over the last year now. It's a pretty established system here at RIAM, and I have taken over from a long-term veteran who had really worked with this system and built it up. And so we're continuing to build upon the system that's here, and trying to use this system to help us make good data-driven decisions in our mill.
Thank you, Reagan. Branko, would you like to introduce yourself?
Yeah, definitely. Hello, everyone. My name is Branko Radulovic. I'm a MES senior engineer at the BBA Incorporated. We are a Canadian multidisciplinary engineering firm, and I specialize in the manufacturing execution systems for different customers. We offer design and implementation, and also we are a certified integrator for the PARCview solutions. So we again help the customers get the best decisions from their data. Thank you. Glad to be here in this panel today.
Thank you, Branko. Scott?
Yeah, thanks, Wayne. I'm Scott Carey. I'm a sales engineer here with dataPARC. I'm a chemical engineer by training, and I've been working with dataPARC in some fashion or another for around 20 years. And today I'll actually speak more from my experience as a dataPARC customer and user at a sugar factory where I worked before this position quite a while ago. So happy to be here. Looking forward to talking through it.
Thanks, guys. So our agenda today, I'll be presenting a little bit on sort of how dataPARC's vision for maximizing the utilization of dataPARC in a control room has evolved over the years, and our users on the panel today will talk about their experiences and successful experiences using dataPARC in their control rooms and in their operations. I'll be the first one talking to you today, and I'm going to talk a little bit about dataPARC's vision for how to use dataPARC effectively in your operation. So empowering control rooms. I've been in the industry quite a while. Control rooms have evolved over the years from panel instruments to DCSs. And DCSs are very good at what they do. They're very good at working with process devices now and knowing what a process event is now, what's happening now. But you usually have limited display area, and when you want to know what's happening in the past, maybe not the best solution. And we feel like PARCview displays are the way to know what is happening overall in your process. Trends give you the road that the process is traveling. Our philosophy is have data up, key data is up all the time. And graphics, using our graphics to give you overview displays that are process allows you to look at a bigger piece of the process on the graphic in near real time but not have to clutter up your DCS displays, which oftentimes you're using to actually operate the process. And also, we feel like operators benefit from being able to see the momentum of the process, not just where I am, but where I am going. So multi-trend, this is sort of our bread and butter tool in dataPARC in the control room. It's a dynamic process visualization. Multi-trends visually illustrate the process's evolving state. You can see how individual data points are changing over time. And this enhances understanding of process dynamics for operators. They can see not only as tag A moves, but they can also see how tag B is also directly reflected by that. It also gives a chance to transition a little more to proactive monitoring. A lot of times DCS screens, you're moving them around. You may not be looking at the exact piece of the process that may be changing. And a multi-trend allows the operator to have all that data in front, and they can go from more reactive, I heard an alarm, to a proactive mode of looking at their process and possibly catching things as they're changing, not before they become an issue. Also, we can simplify process tracking with multi-trend. So well-designed multi-trend provides immediate process insights. Data about a process gathered on a single trend display or on several trends in a multi-trend allows you to sort of get a picture of the entire piece of the process and how it's changing and how it's running. And you could see things rising, falling, stable. Also, speed and oscillation analysis. You could see the rate of change. It might be a tank that is draining that you're going to have to do something about in a half hour based on the trend, or something you might have to do something about in half a day. And a trend allows you to see those kind of pictures and be able to make those kind of determinations. Comprehensive process awareness. Well, what does that mean? It means we could take a look at not just the processes that the individual operator is accountable for, but you can actually broaden the horizons of information available in their control room. So you could see you don't have to call up another department to find out how things are going, or if you see an upset coming in your process and you're trying to troubleshoot it. You can make the data available directly to the operator in this control room all the time. Also, you could gain insight. Operators see this data all the time. They could gain insights about how various process areas impact each other, and get more understanding of cause and effect relationships as their processes change. Continue intuitive learning, and I guess this concept ours is sort of pattern recognition. Your continuing monitoring really gives you an intuitive understanding of sort of how things happen over time. You know, some processes are cyclical, and if you can watch the cycles on a multi-trend and how they affect the rest of the process, you just get a real feel for the pulse of your process as things occur during your shift. Rationalizing process changes. Trends can provide clear evidence of how changes affect the process, and they can also help maybe debunk some misconceptions. When everybody's always trying to make causal relationships and things they see, and sometimes those causal relationships get a little off base, but multi-trends and large amounts of data that you can look at allow you to make those correct causal relationship distinctions in process changes. Graphics. So graphics, yeah, if you looked at my bio, I started a little while ago in industry, and graphics was a very expensive proposition, and over the years, being able to build powerful graphics has become much less expensive, and so they're much more affordable. And large 4K displays are very cost effective in a control room. And we have an example here of sort of a concept that we've been exploring over the last decade, where you take those DCS screens where you try and give a good representation of your process, but because it's also a control screen, a lot of times you have to chop that up a little bit. You might have 10 to 20 DCS displays for a process, and they give you a pretty good view of how things are going on. But you can now leverage dataPARC to show the entire process at a glance. This is a recost area. This is part of a pulp and paper process, part of a pulping process where you're generating cooking chemicals. And this is the entire department on one screen. You could see every flow, and you could put 50, 60, 100 variables on this screen, put it on a nice big 4K monitor, and now you have an accurate representation of what your whole department is doing. Excellent training tool for newer operators to get an understanding of how things happen in a control room. And it also could become a single point of knowledge for what's going on in the process. So having a large display, a large graphic like this with this kind of detail can really facilitate operator understanding of process flow and system interconnections, and have it all in one place. When something's happening in a process, you could step up to the board and look at what's going on in the entire process in real time. So some common pushbacks we get, we go into places, obviously we have a vision that might be a little different than what some people have done. So some of the pushbacks we hear is too many tags. That's one we hear from people often. If we put up half a dozen multi-trend screens and they've got 50 tags on every screen, you have 100 traces spread across a dozen or 2 dozen trends. And someone says no one can pay attention to that many trends or screens at once. Well, okay, you're right. I am not going to know what 300 data points are doing instantaneously. But what we do is we tend to build a shift consensus between all the shifts on a process on what the always up trends are. And we make those trends always up. These are the ones that will always be displayed on these screens. The power that gives folks is that gives them pattern recognition. You start seeing what does not look normal. When you sit in front of a screen 40 weeks a year, 50 weeks a year, and you pull a full shift, and you start knowing what those screens should look like. And if, for example, in many control rooms where an operator might be a roaming position where they're not always sitting in their chair, they walk in, and how they know their process, they can catch up on the process at a glance if they look up at all the multi-trends, because they're going to show them exactly what the process is doing in toto while they were away. And we also work very hard. We think it's a very good thing to get operators are vested in the displays, because we put on them what they ask for. And our almost universal experience is they always ask for more over time, not less. Another common pushback we get is this software is for engineers. What if operators mess it up? Well, first, train them. We could turn an operator into an expert in trend design with 2 hours of training, and then they could build as many trends as they want, look at any information in the plant that you make available to them. We allow anyone to explore, this allows anyone to explore the data and learn from it. It's not just limited to technically trained personnel, but just any personnel that has an interest in the data and can derive value from looking at the data can look at it with a dataPARC. And mostly in PARCview, most of it's about looking at data, not editing data. Of course, the lab people may be using it to enter lab data, and they're the one they're creating data as they enter it. But most people are just consumers of data, and the multi-trend is the way many people consume it, and it's very easy to teach them that. Another thing, and it has just been going on even as when I was back in a plant, was PCA tools and AI tools. There was always somebody coming by and talking about presenting operators with a simplified system of health indicators in a process using modeling or AI that should give the operators a smart heads up on what to look for, not deluge them with information. And maybe we should use those tools. Well, those tools require a lot of expertise and need to be developed and trained. They're not very simple to implement, and processes are constantly evolving. We're constantly trying tweak more out of our processes and drive a environment of constant improvement. And training data sets for these tools can become a constant battle. Your process can drift, hopefully in the good direction, and the tools may no longer be applicable as they were trained when you originally put the project in. And operators are intelligence assets, and they're constantly training themselves. They have more time on the process than anybody else, and their knowledge can be evolved into trends and graphics to reflect those process changes and their insights. And that's very easy to do compared to brooming a 2-year data set model and starting over. So we feel like our tool can be much more reactive and proactive in staying at the cutting edge of your process capability. So our trended graphics philosophy, what's a basic philosophy we go into at a place? The trend is the tool to stabilize and improve the process. It can put the most data the quickest in front of an operator and supervision, and it could give them a real overall intuitive feel for what the process momentum is with very modest effort in developing the trends for a control room. And multi-trends do allow operators, you could build links into them, you can clone zoom in on trends. It allows operators to be able to focus on specific data as needed, but still see the big picture all the time. Trends in control rooms do need to evolve, but deliberately. We feel like your initial build, you need consensus from all shifts and supervision, and put that information in front of the operators, put the information they need in front of them, but be open to evolving it as needed, but keeping the continuity as much as possible, because that enhances pattern recognition and gets them used to looking at the trends and being able to see subtle changes because they see the same information week in and week out. Graphics allow the design of process flow diagrams without the hindrance of control activities. You could get the whole process on a 4K display. Not too tough to keep it current. When somebody goes out and puts in new pumps or whatever, you just get them added to the display as soon as you get them added to your historian. And it becomes an excellent training tool. You could stand in front of real-time information about what the process is doing right now. And if you build that display properly, you could give somebody that's new to the process a very detailed vision of how the process actually works. Both allow operators to see beyond the process. I put on here, I do not wait for lab report from quality. Data is there as it is entered. So it can be an enhancement to communication that requires less effort for operators to communicate effectively. Final thoughts, control room tips. DCS displays do DCS things well. Let them. Set them up in a way that makes sense for you with the instantaneous alarming. For information that doesn't require right now knowledge, long-term tank level and how tank levels are trending, where process flows are. Trends and graphics do that job just better than DCS displays, and you don't want to tie DCS displays up for operators to try and look at that stuff when you have a tool where you could jam more information easier to get at, like the trends, and also a little bit less expensive to deploy a screen in dataPARC than it is a DCS screen. Speak with data. Once you get this kind of infrastructure in your plant, in a morning meeting, show a trend. If this happened like this over this period of time and operations did this to fix it. If you have a process upset conditions you need to talk about in the morning meeting, just show up with a trend that shows everything that happens. Everybody understands that. It becomes very, very clear rather than maybe a verbal dialogue about it. Make data you need to talk about. Accountability and knowledge transfer. Having this kind of data is going to really transform how you can understand your process. And like I said here, be this guy. So he's looking into the future with his modern dataPARC trends and maybe not paying quite as much attention to the dial gauges that look like they're from the 60s. That's all I had for now. I'd like to turn you over to Reagan and talk a little bit about some operator experiences with PARCview at RIAM.
Thanks, Wayne. Yeah, so excited to talk with y'all for a few minutes about some of what our operators have experienced using PARCview here at RIAM. So as I was out talking with operators in different control rooms in our different areas here at the mill, one of the constant things that I kept hearing about how they're using is that they really like to use it for its trending capabilities. That's a lot of what Wayne was just talking about. So compared to our DCS systems, PARCview has much better trending capabilities. With the DCS systems, we are able to trend some, but we're not able to trend back in time for a very long period of time. And we're also not able to really add multiple tags to a trend, at least do that very easily. With PARCview, it's very simple to drag and drop multiple tags onto a trend all at once. And the operators really like the ease with which they can do that. And then along with that, we're also able to very easily shorten or lengthen the time span that we're looking at on a trend. And so operators can go back, 3 days with just the click of a mouse to see how their process has been operating over that time period. It's very easy for them to do, and pretty much across the board, they all talked about how that's one of their favorite things about PARCview. Something else that most all of our operators use PARCview for is just continuous monitoring of different key parameters for whatever area they're working in. It could be something like temperature, pressure, tank level, things like that. But they really like the ability to have those multi-trends that, again, Wayne was talking about, to have those multi-trends up there with all of their different key variables, so that they can just constantly have those in front of them all throughout their shift. With the DCS system, all of those tags are in the DCS system, and that's where we're getting the data from. But in order to view that data in the DCS system, you're going to have to click back and forth between all of your different DCS pages, and you're not going to be able to have all that information right in front of you at the same time. But PARCview allows them to do that, and they really like being able to have those. Have all of their key parameters up in front of them all day long, so they can just glance up and see, okay, yeah, my temperature is where it should be. Oh, hey, that tank level is dropping out. I need to go take a look at that. And so it really does help them ensure that the process is operating like they want it to be operating. They can use the multi-trends to quickly identify where there is a problem. And you don't have to hope that you have the right DCS screen open when something goes wrong, so that you can catch it right away instead of a problem being ongoing for 30 minutes before you see the correct screen. Something that, and I'll touch on this a little bit more later on, but something that our operators find very useful in process monitoring with PARCview is to have the same tags on the same trends on their same screens day after day. And so they're sitting there at their desk, and they've got a screen up in the top left corner of their work area, and that screen is always going to have a trend that has pressure, temperature, and flow data for this specific part of their process. So they know, all right, I just have to glance right up here, just get the information that I need, and there's no hunting. It's pretty much, at the speed of thought, they're getting the data that they need. So we talked about process monitoring and how they can very quickly they can just glance over and see, okay, yeah, my process is running good, or hey, there's something a little squirrely here that I need to look into. PARCview, the benefits of PARCview don't stop with just noticing that something is wrong. PARCview really helps our operators be able to start actually troubleshooting what specifically is the problem. And again, this gets back to the ease with which they're able to trend things, the fact that you can drag and drop tags very, very quickly onto a trend. Say that they look at their trend and they notice, hey, over the last 4 hours, the temperature in this part of my process has slowly been climbing. I wasn't expecting that. I need to look and see exactly what's going on there. Well, they can then go and find a flow tag for their chilled water flow. You can pull the tags for the valve position on that chilled water line. You can drop those right onto the trend with your temperature tag, the initial tag that they noticed was something was going wrong with. And they can very quickly see, okay, yeah, it looks like this was the problem. This valve started closing off for some reason here right about 4 hours ago, and my temperature started climbing. So it's very easy for them to troubleshoot the issues that they do notice using PARCview trends. Something else that is helpful, and some of our areas use this, is the center lines in PARCview as well. These are especially useful when we're like starting up from, maybe the process was down for one reason or another. You can start up using a center line to show you, okay, yeah, this was what a good startup looked like 3 months ago. So I'm going to try and hit this value for this parameter, and I'm going to trust that's probably going to be one of that's how I'm going to get a good quick startup. It's also, center lines are also helpful because, again, they help you very quickly notice that a variable is out of its normal operating condition. Something else that our operators use PARCview for pretty regularly is to have a broader understanding of what's going on in different areas in the mill. I was talking with one of our lead operators over in our recovery boiler area, and he was telling me about how in the recovery area, that part of our process is very close coupled to our brown stock washers, right? We're taking the filtrate from the brown stock washers over to recovery to recover those spent cooking chemicals. And so I was talking with the lead op in recovery, and he was telling me about how they have a general mill overview screen. It shows all of our different processes, fiber lines, machines, recovery, all of it's on there. The graphic is very intuitive, very easy to understand. And he says they keep that graphic up there on their wall all day long. And so he can glance over and see, okay, hey, they're having an upset on the brown stock washers. That means that my weak liquor supply is about to drop off, and I need to go ahead and proactively make some adjustments to mitigate those impacts here in recovery. He doesn't have to wait for the pulp mill shift supervisor to give him a phone call and say, hey, we're having issues on the brown stocks. Just want to let you know so that you can make your adjustments. He doesn't have to wait for that phone call because sometimes that phone call might not even come. Shift supervisors get busy dealing with whatever the issue is. They may forget to call and alert the other areas that need to know that there's a problem going on. Well, PARCview really eliminates the dependency on someone actually picking up the phone and making that call, because someone over in the recovery control room can just glance up at that mill overview and see, hey, yeah, there's something going on in the brown stocks. I'm going to go ahead and start making some adjustments here. And it really mitigates an issue in one part of the mill propagating to other parts of the mill as well. So just a few takeaways from the conversations that I've had with our lead operators throughout the mill. This first one was actually kind of funny. So I was going out in the mill and just doing some interviews, talking with operators about how they use PARCview day to day. And so I'm walking in there and I'm asking them, what do you use PARCview for in your day-to-day job? And at least once, I think maybe twice, like one of the first answers I got was kind of like, well, why are you asking that? Or y'all aren't thinking about getting rid of PARCview, are you? Because they were concerned, and I alleviated their fears. And I was like, no, I'm trying to just gather information. I've got this webinar, that kind of thing. But they were very concerned when they thought that we might be getting rid of PARCview, because it is something that they use every day. And it is very much a part of their routine, and it is a tool that they're using constantly out there. And it's been here at our mill for a while now. All the operators that I talked to, by the time that they had reached the lead operator role that they're currently in, we were already using PARCview. So none of them. The tool is very ingrained in our culture here. It is something that is just constantly being used. Most operating areas have what standard multi-trends, if you will. that are saved, and those multi-trends are always open on their screens there in their operating areas. One thing that they like to use is the start display feature in PARCview, to where you can save, you can open trends and then place them wherever you want them on your screens, and then save those trends in those screen locations as your start displays, so that whenever you launch PARCview, each of those trends, each of those multi-trends is going to open in that exact location on your computer screens. And our operators really like that function, because then again, it cuts down on time that they would have to spend going and hunting through the folder tree to find their trends and then rearranging them exactly how they like them. It just PARCview just launches with the data right where they need it. And then finally, I was talking with one of the lead ops about how he learned to use PARCview. And his response was that he really didn't have any training. It was really just hands-on experience, on the job training, if you will. And he was very adept at using PARCview. He knew how to get exactly what he needed with the software. I think just kind of showcasing that it is a fairly user-friendly piece, a user-friendly tool. That he was just able to pick it up through some hands-on experience on the job. So these are just some of the key takeaways that we have gotten from our operators and their use of PARCview. Again, it's a very ingrained tool. They're using it every day, every shift. It really helps them organize their workflow, and it has been fairly easy for them to learn how to use as well. So those have been some of our experiences here at RIAM using PARCview in the control rooms.
Thank you very much, Reagan. I want to mention that we do have a question panel in the webinar interface. So if you have any questions for Reagan, please type them in there. We'll take a look at them and address those at the end of the presentation. I'd like to turn it over to Branko now, who's going to talk a little bit about how his experience is integrating manufacturing execution systems with PARCview. Branko?
Yes, thank you, Wayne. Hello, everyone. So yeah, let's take a little bit a closer look how both of these systems are coexisting together in the most of the control rooms. So from our current projects, we have seen that the operational clients want to be more independent on how their data is structured and also represented. And the operational teams are providing different tools to operators to help them stay on track on their production, to ensure that the quality is good, to ensure also that the performance of the equipment are up and running, and also to ensure health and safety. So they have also put in these two systems that we're going to be talking about today, an MES system and also a suite of PARCview applications. So just to give you a little quick definition of MES, basically the letters, they stand for Manufacturing Execution System. And this is where the system will provide a contextualized view for the data that we're going to be looking at. And we can also see some of the modules that MES system will offer, for example, everything that has to be linked with a real-time production tracking. So for us, that means is there has to be an order created somewhere from another system. There will be a start order. That order will generate a lot. There will be a batch number that's going to be created. And then the equipment will produce something during that start and end time. And that will, at the end, be closed when we complete this action. So, and moving down for the other option is that we have quality management, is where the MES system will give you specifications for your lot, for your batch from either the MES system or another external system like a laboratory information management system. And that will also be linked to performance analysis. These are different tools to give you insights of how well you're doing with your production. For example, we're going to have built-in modules that will calculate the overall equipment efficiency, which is also known as the OEE. So some of those systems will provide you out-of-the-box calculations for that. And to support the operator in his productions, there's also different accesses that are given with the document management links that will provide links to the standard operating procedures, different instructions, health and safety guidelines, and so on. And one of the key important links for the MES system is that it integrates as well with the maintenance systems, such as SAP PM systems. So the integration is done through the historian, through MES SQL tables, and so on. And now when we look at it from a PARCview side, in that same scope of the data, where we're getting is the real-time data visualization. So this means that we have access to the data as it changes. And additionally, the PARCview application, the trending, the capacity that we have seen that's been used in other industries, it can access the MES data as well. So it's not only limited to a historian, but can also go into any specific MES system. So when we have that data, we need to present it in some sort of a way that's efficient for the operator to see it. And PARCview has these customizable dashboards. They're called PARC graphics that can be adapted to, let's say, replicate DCS screens, as we have seen that in Wayne's presentations. And that also is very simple to do. Many of the tags that are in different sources can be taken and simply drag and dropped into analysis, so we can see what's going to be happening in our process before that lot is completed. So that gives us a quicker insight on the data. And if there are some issues, we can have alarm management. We can also link a reason trees to identify or to prove what really happened during this event that we consider to be part of the alarm. And what I find also very important is that we have access to historical data access, where we can represent large chunks of data by using smart algorithms to do that. And we can retrieve a great amount of data relatively quickly. So I think the key here, the key takeaway is to focus on agility, is what operator needs to troubleshoot his process, and also the capacity, how to quickly adapt to a change if needed, and also add different operating parameters. So if we remind ourselves how many systems the operator is supposed to look at every minute, it's important to just analyze and understand that the real-time data analysis and the response that they get is also critical to their operations. So the MES system will manage and document this manufacturing process, and this is something that's called the genealogy. And down further the line, it will be very suitable for something doing, let's say, an important recall or looking back at the quality that they're doing. So this will be a critical part that could be done in the MES. At the same time, PARCview comes in with real-time data visualization. You can have multi-trend, as you were seeing here. You can also add different tags from another system and immediately see what's going on and how the system is, how the process is being varied in the real time. Also, we are able to integrate this for operators using their SCADA systems. So that's also important to know that those performances can be tracked into these trends. And that also enables immediate adjustments. So if something needs to be changed, it can be done right away. We can see a trend or that's going towards a failure, then we can quickly react. Maybe we need to slow down equipment to make sure that the line does not stop. And ultimately, as an example, in the MES, for when it detects a production line deviation, we'll see that the PARCview can display the data for the operator, and then that can be used for the decision making, and also can be ultimately represented in the center line screens that we can see that from Reagan that was showing earlier, and easier to manage. So since we're speaking of the machine equipment, we can not skip the part of the predictive maintenance and also different initiatives to reduce downtime. So MES will track downtime for the machine and the different equipments that are linked to it and have access to its history. And again, PARCview has a great capacity to monitor real-time data and also is able to track downtimes by using an alarms, and also going back and linking that to a reason tree where we can explain what different anomalies we had on the system. So there is a part of the integration that needs to be done and ensure that all the data is correctly synced. And also that data, once we are able to justify it, there is a potential for the operators in that same control room to get some reports, for example, out of the box. So currently now we have an example of a Pareto screen that basically gives us the top causes of a certain equipment that was in problem for that time period. And most importantly as well, quality is an important factor when we are considering our operations. So both MES and PARCview are kind of tightly linked in ensuring that the process and the quality satisfies what our customers are asking to be produced. So again, when we monitor in quality, it's important to see it in real time. So you don't have to wait at the end of the batch to have your aggregates come in and all the contextualized information be available. And PARCview can offer you that by the live trends. So you can monitor exactly what's going on and see how everything is varying in time. So you can maybe take a better decision immediately from the control room and talk to the other operators and call maybe another department and say, hey, what's going on at your line? Oh, yeah, something's going on. So let me reduce the speed. All right, thanks for the heads up. So that's also kind of that communication that you will get once the systems are in place. And yeah, so that's in terms of the alert being for the operators to be alerted if they can use the system to get their specifications. So in the centerline display, which is the display here shown in the left box, you can have for each column, could be your batch or could be your lot, or could be, for example, a per hour production. And then you can have a set of different variables with the alarms, with the lower specifications, target and upper specifications defined to help guide the operator on his decisions that he needs to take in the control room. So ultimately that gives us a possibility to maintain quality, reduce the waste, and always ensure that the products are done, produced the same way. So when we come to the closing where the systems have to track efficiently the resources, the MES system will support something that's called the bill of material. So that's going to be an advantage for that, is you're going to be able to know what goes into a product that was produced, ultimately linking that to a genealogy of production. So that can be also a factor to consider in terms of what goes into the production. And alternatively, PARCview provides the real-time visualization on that, is to be able to monitor what's going on exactly, how that product is being consumed, and you can see it as a trend or a graph that's varying in time or on deploy. So that can also be built into the operator control room, where he can be the owner of that. And once they identify these parameters that are being important for the production, they can be added later into the MES as a part of that bill of material to explain the genealogy and moving on. So the systems could be complementary. One is more of a real-time PARCview, so it gives you that insights, and then from those parameters that you identify, you can link them into the MES space and ensure that your products are consistently produced in later phases as well. So exactly that. And one other point to add to that is when we calculating different aspects of that is to save money, reduce weight and waste, and to enhance the efficiency. There is a feature called the evidence calculations that could be attached to each event where your alarm has been triggered, to make sure that you are calculating this waste, or to calculate how much money your cost is going towards this production. And then you can run a Pareto screen to estimate what you should be running your improvement initiatives. And that can also be integrated for the MES via integration of a databases, and to get the real-time costing as well that we can see. So I think in summary, what we have seen from these systems, they're very complementary, is to decide to what level, what system needs to be put at first, and also how these systems will empower the operators to have more efficient operations. So yeah, thank you for that.
All right, Branko, thank you very much. That was very informative. We're going to turn this over to Scott right now, and he's going to talk about some of his experience at One Sugar Factory's journey with dataPARC. Scott?
Yeah, thanks, Wayne. I just want to spend a little time talking today about sort of the process of how you get from a sort of a control room of the classic era to the digitally transformed control room, which I guess is really one big step in a organization's total digital transformation. In my experience, it was at a beet sugar processing facility, but I think the experience and the process is pretty similar across a lot of industries. We started with, we had one central control room in the factory, but there were a number of satellite control rooms at other stations around the factory. And depending on, in the central room, we had 2 DCS HMI screens in front of each operator. At some of the satellite stations, it was just a single screen. And then, of course, the DCS was, some of it was a legacy system. Some of it was had been more recently upgraded, but in the best case, it offered trending capability of, maybe 8 hours previous, and the trends were very difficult to configure. They kind of had to be pre-configured, and the operators could just select them. They didn't have any control over what they looked like. And then, of course, you popped one up, and it occupied part of your HMI screen, so you couldn't see part of what you're supposed to be operating behind it. And frankly, the operators didn't use them. I don't think I could count on one hand the number of times I saw those trends displayed on an operator screen whenever I would go visit the control room and chat with the operators. So in addition to their automated process systems, one thing that's maybe a little bit unique in the sugar industry, I think it's also pretty common in other food and beverage and life sciences based industries, is there's a lot of laboratory analysis for process control in addition to quality control. So the operators actually, they operate by a fair amount of lab data on an hourly basis. And the original system that we had was a homegrown system called LabNet that each operator station had a PC with a small monitor sitting there, and LabNet was displayed in a tabular format. It was just a time column down the left side and then columns for each lab sample across the top, and it was just a big table of numbers. And that was heavily used, but there was really no way to trend that data, at least not that operators could utilize. And it was a very archaic system with no support. So what the operators did, I mean, the operators are going to do the best with the tools you give them, right? So they really were focused on the snapshot of the process. They could see what the situation was right now on their screens and in LabNet, and they knew whether they were in spec or not, but they didn't always know how they got there or what direction they were moving. So they had very little concept of dynamics. How fast am I moving up or down? What's really happening in the time scale? And one of the other big things was when an incident would occur, there would be a lot of kind of different perspectives between operators and foremen and whoever else was involved about what really happened and why did it happen and how did it happen, at the end of a shift or whenever the conversation might be happening. It was just it was difficult to align because not everybody had the same understanding and the same memory of what happened during the process, upset or whatever it was. And then also, at shift change, they had handwritten shift logs that they would work from and leave behind for the next shift, and they'd have a short conversation. But you got to remember, these operators have been on shift for 12 hours. They're tired. They're ready to go home. So there's oftentimes a lot of details that are missed. Sometimes things happen during the day on their shift that seem insignificant to them, and then later you find out that they led to something much more significant in the next shift. So that may not be shared because it just didn't come up as a major issue to them. So these were all concerns that we had, and I think they're common concerns across a lot of industries that are in that situation. So whenever we decided on implementing a tool like dataPARC, we looked at several options and ultimately selected dataPARC as our tool for the whole company. We had 3 operating facilities, and I was based in the one. What we did for the control room was they still have their 2 DCS screens in front of them in the main control room. But then we were, I think we upgraded, but basically still just using a regular PC like the LabNet PC was before. Instead of having a small screen with nothing but the LabNet tabular view on it, we connected a pair of basically big screen TVs to that PC and hung them on the wall up behind their console. And like Wayne said, those things are really pretty cheap. And suddenly we had the real estate to display a lot of information. And the other thing that we did, and this took a little more time, initially we simply connected the old LabNet data to dataPARC so they could view the old database on their dataPARC trends and displays. But over time, we actually replaced that old LabNet system with the dataPARC MDE manual data entry system, so that all the calculations were done and all the data entry was done directly in dataPARC. So it consolidated that into the dataPARC platform. And one thing we found, and this was all occurring, it's been a number of years ago, but at about the time when we had a lot of a previous generation retiring and kind of moving out of the control room, and a lot of younger folks moving in that grew up in what I would call the video game generation. And they were very comfortable with a piece of software like dataPARC. And I think it was mentioned earlier that operators pick this sort of thing up really fast. And partially that's just the modern age, and partially that's the ease of use and intuitiveness of dataPARC. But they were able to build their own custom trends very quickly. And one thing that we did that might be a little different than some other organizations is we did not necessarily standardize our multi-trend views across all shifts. We gave each operator the freedom to build their own custom multi-trends for the parameters and the arrangement of trend lines and views that they felt worked best for them. And of course, once they did that, they weren't changing them all the time. So for each operator, every time he came on shift, he would open his set of trends and put them on those big screens. And it was still a very consistent, same view every time. And he got to where he got, a very easy visual recognition of where the process was, but it might have been different from his cohort on a different shift. And that's okay in my mind anyway, because part of what that did was it really got a lot of buy-in from the operators, because they're only going to use a tool that they feel like they own and that they trust. And so that was part of our efforts to build trust among the operators. So I want to just cover a few key takeaways also after, going through the process and working with it for a number of years. One thing we did that at first may seem a little bit redundant, but we actually took all of the DCS HMI screens that the operators were used to looking at and were used to interacting with for control, and we basically mirrored those as dataPARC graphics. So we took the image and all the visual picture of that screen, and then overlaid that with dataPARC live data connections in a PARC graphics view. And what that did was it created a very familiar interface to the operators. So when they were ready to build trends or wanted to make any changes to their own trends or look at something ad hoc, maybe that they were just trying to investigate something besides what they always had on the screen, they could open these displays and their data parameters were in the same locations that they were used to seeing on the DCS. So all they had to do was double click one of those numbers and a trend would pop up, and then they could drag and drop more onto it from that display. And that there wasn't any question about, do I have the right tag? Am I looking at the right data? In addition to that, we also tried to write the tag descriptions whenever we built the tag list in dataPARC using the same nomenclature that the operators use. It's real easy to just kind of copy and paste loop numbers and that sort of thing into tag descriptions, which for those folks that are super familiar with the inner workings of the control system, that works fine. But operators generally have a little bit of more of a colloquial lingo for the process and the elements of the process. And so if you can kind of pay attention to that and incorporate that into your tag descriptions, that also makes it the system more familiar to them, makes it easier for them to locate the tags that they need and get them on trends and displays as they need to. Another thing that we found out pretty quickly is that operators are really good at letting us know if there are any issues with the dataPARC system. Whether it's a tag has gone flatlined, it's not reporting data anymore, or there's a discrepancy between the value they're seeing on a tag and the value they're seeing on their DCS screen, or any sort of minor issue like that might come up. They were pretty good at letting us know right away, and so in return, in order to maintain that trust in the system, it was on us engineers to respond to that and rectify those little issues as quickly as we could. And in most cases, it was minor stuff. Someone had changed something on the DCS and it didn't get updated in the tag list on dataPARC, or some small issue that we were able to fix. But by doing so, the operators saw that we cared about the system and that we cared about their input when they saw an issue, and it just allowed them to trust it a lot more and utilize it to its full potential. And the last thing I wanted to mention was that we found that trending was a great training tool. So if you had an incident, some sort of process upset, operator, you knew something went wrong after the fact, he kind of maybe didn't understand completely why. If you have a trending tool that you can sit down with the operator and go back and look and pull several variables together, maybe from different data sources, lab, process data, whatever it is, and explain that to them while looking at the same data and understanding it on a trend, it just goes so much farther than trying to give them, some kind of theory basis from something you learned in college that maybe doesn't resonate with them. And the other thing that I want to mention, and this often gets overlooked, is we're not only using this tool to troubleshoot or forensically investigate upsets and problems, but we can also utilize dataPARC to identify and celebrate when things go well, when things are going correctly. dataPARC actually has a feature that allows you to save what they call golden runs, where you can actually you have a set of data points and you save a time span, and it calculates the statistics on when the process is running correctly. But that can be extended to also training with operators. Maybe you've got a new operator on shift and they're a little confused about how to run a certain type of batch. Well, you can sit down with them and pull up that batch trend from when it ran well, and show them the shape of the trend and what the different parameters were doing, and explain all that way. And the other thing that's useful is in the graphics displays, we have the playback feature, where you can actually scroll back in time on a graphics display and see a snapshot of what the conditions were in a good state, or perhaps maybe also a bad state. But again, having real data and looking at the same information in front of you and the operator during a training session of any sort is a huge benefit. So those are the takeaways that I just wanted to kind of cover here today. And I think, you know, it really transformed the way we operated to put dataPARC in the control room. And to this day, I don't still work there, but I'm close with the folks that work there, and they're still adding new data sources and trying new ways to utilize dataPARC today. Almost, what has it been, 12 or 13 years since we put dataPARC in the control room. So it's a very sustainable benefit that they're getting from that.
Thank you very much, Scott. That ends the prepared part of our presentation. We'd now like to review any questions that were posed to us. And if you look at your GoToMeeting interface, there is a place where you could type questions to us if you'd like. I typed a few answers into the comments, I think, against the wrong questions, but one of the big ones came up was somebody really liked our recovery boiler graphic and asked us where we got it. And I had to reply, we drew it. We do provide some clip art packages with our graphics package. It's a sort of standard set of industry clip art. But for something as specialty as a recovery boiler, we end up drawing it ourselves. We also can leverage, for example, if you have a recovery boiler that had AutoCAD drawings as part of its construction, you can export those to .svg format, scalar vectorable graphics, which is a public domain graphics formatting that we can then import and use in our graphics as a basis for the graphics. And let's see. One person asked how do we get operator buy-in? How long does that take? And my one anecdotal story on that is I was training an operator in the control room on the job, took off an hour for dinner. I came back, and not only had that operator redone all my trends and put dozens of new traces on all the trends, but he figured out how to set up the color scheme of the trends so that it matched the Arkansas Razorbacks. And that was sort of a surprise when I came back to the control room. So I think we have another couple of questions, but we are up against it on time, and I think we're going to post the rest of the questions to the community forum. Thank you. Everybody have a great day.